Good evening, scholars. Mr. Spears here. Tonight's lesson we're learning how to balance chemical equations using the box method. Throughout this video I'll be working through 4 examples. Pause and rewind as often as you need as you develop your skill. In our first example we are to balance a chemical equation, the reaction of nitrogen gas with hydrogen gas to yield liquid ammonia. To begin to balance this reaction, I'm going to make a list of all the different types of atoms on the reactant side and the product side of the arrow. Remember that the arrow points to the product side and points away from the reactant side. Scanning across the equation, I can see that there are 2 types of atoms. There are nitrogen atoms and hydrogen atoms. Looking on the left side, the reactant side of the arrow, I see that there are 2 nitrogen atoms and 2 hydrogen atoms. Looking at the product side, the right side of the arrow, there is 1 nitrogen atom and 3 hydrogen atoms. By just looking at my list, I can see that I have an imbalance of both nitrogen and hydrogen atoms. To remedy this, I'm going to begin to balance this equation. I'm going to start by putting a box around each reactant and product. Next, what I'm going to do is I'm going to take a look here at my nitrogen. I realize that I need to get 1 more nitrogen on the product side so it matches the number I have on the reactant side. I take a look at the product side, the side that the arrow is pointing to. Only 1 box on the product side contains nitrogen atoms, and that is an ammonia box, NH3. So I'm going to add a second box of NH3 to my product side, and now if I count up the nitrogen atoms, I have 2 on the product side to match the 2 I already have on the reactant side. So the nitrogens are balanced. However, that box of ammonia that I added to balance out the nitrogens also contained hydrogen atoms. So if I do a quick recount of my inventory list, I see that I now have 6 hydrogen atoms on the product side. So taking a look at my hydrogen atoms, I have more hydrogen on the product side than the reactant side. I need to get 4 more hydrogens on the reactant side of the arrow. Looking at the reactant side, there are 2 boxes, but only 1 box contains hydrogen atoms, and that's an H2 molecule box. If I add 2 more boxes of hydrogen molecule, I will get a total of 6 hydrogen atoms on the reactant side. Now, taking a look at my list, I have a balance of both nitrogen and hydrogen atoms. I'm almost done. Lastly, I want to determine the coefficients of the reactants and products in the chemical equation. This can be accomplished by simply adding up the boxes. I have 1 box of nitrogen molecules, I have 3 boxes of hydrogen molecule, and I have 2 boxes of ammonia NH3 molecules. Okay, to write the balanced chemical equation, what I'm going to do is I'm going to write out the chemical equation minus the boxes. N2 gas plus 3 hydrogen molecules yields 2 liquid ammonia molecules. Now the coefficient of 1 was left off of my chemical equation because in math and science the number 1 is understood. In example 2, we are to write a balanced chemical equation of the decomposition of hydrocyanic acid into hydrogen gas, solid carbon, and nitrogen gas. I notice that there is hydrogen, carbon, and nitrogen atoms in this reaction. Looking at the reactant side, the side that the arrow points away, I see that there is just simply 1 hydrogen atom on that side of the arrow. I see that there is also just 1 carbon atom on the reactant side and 1 nitrogen atom. Now looking at the product side, the side that the arrow points to, I notice there are 2 hydrogen atoms, 1 carbon atom, and 2 nitrogen atoms. Alright, looking at my list, I can see that the hydrogen and nitrogen atoms are not balanced on both sides of the arrow. So what I'm going to do is I'm going to put a box around each reactant and product. Beginning with hydrogen, I notice that there's more hydrogen on the product side than the reactant side, so I need to get 1 more hydrogen on the left side of the arrow. The box that contains hydrogen on the left side of the arrow is the hydrocyanic acid box. So adding 1 more HCN box will give me the extra hydrogen that I need. I now have 2 hydrogens on the reactant side. But that box of hydrocyanic acid not only contained hydrogen atoms, it also contained carbon and nitrogen atoms. So I need to readjust my list. I now have 2 carbon atoms on the reactant side and 2 nitrogen atoms on the reactant side. You'll notice that with this step, I not only balanced the hydrogen atoms, but I also balanced the nitrogen atoms. This simply leaves only carbon unbalanced in this chemical equation. So to get more carbon on the product side, I find the box that contains carbon, I draw one more box, and now I have 2 carbon atoms on the product side. Looking over my list, I can see I have the same number of hydrogen, carbon, and nitrogen atoms on both the reactant and product side. So to get my coefficients, what I'm going to do is I'm going to add up my boxes. I have 2 hydrocyanic acid molecules, I have 1 hydrogen molecule, 2 carbon atoms, and 1 nitrogen molecule. To finish up, I'm going to write the balanced chemical equation. Remember, leave the boxes off. Do not write the coefficient of 1. And so I get for my balanced chemical equation 2 solid hydrocyanic acid molecules decompose to give me a hydrogen molecule, 2 carbon atoms, and 1 nitrogen gas molecule. In example 3, we are to balance a chemical equation of the reaction of propane C3H8 with oxygen gas to produce carbon dioxide and water. First thing I'm going to do is to make an inventory list of the atoms in this reaction. I notice across this chemical equation I have carbon, hydrogen, and oxygen. On the reactant side I have 3 carbons, 8 hydrogens, and 2 oxygens. On the product side I have 1 carbon, 2 hydrogens, and 3 oxygens. Next, I'm going to put a box around each reactant and product. And then starting with carbon, I notice that there are 2 more carbon atoms on the reactant side than on the product side. So going over to the right side of the arrow, I notice that the only box that contains carbon is a carbon dioxide box. So I'm going to add 2 more carbon dioxide molecules so that I can have a total of 3 carbons on the product side. However, when I add boxes of carbon dioxide, I not only add carbon atoms, I also add oxygen atoms. So readjusting my list to account for this extra oxygen, I now have a total of 7 oxygen atoms on the product side. Next, I want to balance the hydrogen atoms. There are 6 more hydrogen atoms on the reactant side than on the product side. Looking at the product side, there's only 1 box that contains hydrogen atoms, and that is a water box. In 1 water box, there are 2 hydrogen atoms. So in order to get 6, I just simply need to add 3 more boxes of water. Now when I add up the total number of hydrogen atoms, I now have 8 hydrogen atoms on the product side. Now you see again that this box of water not only contains hydrogen atoms, it also contains oxygen atoms. So I need to readjust my list to account for this extra oxygen added. So looking at the product side, I have 6 oxygens from the carbon dioxides and 4 oxygens from the waters for a total of 10 oxygen atoms. With the carbon and hydrogen atoms balanced on both sides, all that's left are the oxygen atoms. I have 8 more oxygen atoms on the product side than I do the reactant side. So to get 8 more oxygen atoms on the reactant side, I find the box that contains oxygen. In an oxygen molecule box, there comes 2 oxygen atoms, so all I need to do is add 4 more boxes. And now I have a total of 10 oxygen atoms on the reactant side. Looking at my list, carbon atoms, hydrogen atoms, and oxygen atoms are all balanced from the reactant to the product side. So now what I'm going to do is find out my coefficients by adding up the boxes. I have 1 propane, 5 oxygen molecules, 3 carbon dioxide molecules, and 4 water molecules. To write the chemical equation, I'm going to leave off the boxes along with coefficients of 1, and I get C3H8 gas plus 5 oxygen molecules yields 3 carbon dioxide molecules and 4 water molecules. In our final example, we have solid magnesium reacting with aqueous silver chloride. Aqueous simply means that the silver chloride is dissolved in water. These two reactants react and produce solid silver and aqueous magnesium chloride. To balance the chemical equation, by now you know that we need to make a list of atoms on the reactant side and product side. Looking across the equation, I see that there's magnesium, silver, and chlorine in this chemical equation. On the reactant side, I have one magnesium, one silver, and one chlorine atom. On the product side, I have one silver atom, I have one magnesium atom, but I have two chlorine atoms. Next, I want to put a box around each reactant and product. And in looking at my list, the magnesium and silver are balanced, but the chlorine is not. I need to get one more chlorine on the reactant side. So looking at the boxes on the reactant side, only one box contains chlorine. That's a silver chloride box. So I add one box of silver chloride. That now gives me two chlorines on the reactant side. But that box also contained a silver atom. So readjusting my list, I now have two silver atoms on the reactant side. This now causes an imbalance. I have more silver on the reactant side than on the product side. So I needed to go to the product side, find the box that contains silver, and add one more box. And now I have two silver atoms on the product side. As I look across the list, the magnesium, the silver, and the chlorine is all balanced. Next, I want to find the coefficients: one magnesium, two silver chlorides, two silver atoms, and one magnesium chloride compound. To finish up and write my balanced chemical equation, I'm going to leave off coefficients of 1 in the boxes from what I have written up above. So my balanced chemical equation becomes one magnesium atom reacts with two silver chlorides to yield two silver atoms and one magnesium chloride compound. If you have any questions after watching this video, don't hesitate to contact me. My contact information is shown. Have a great day and happy studying.